Morning, everyone. Staying out of the limelight. My name is Desiree Nortje, and I work for Transurban. So just a very quick introduction. Whoops, wrong way. Yep. I will give a very quick introduction to Transurban. So we own CityLink, that's Western Link up to Tullamarine, and Southern Link, which is from Balti Bridge going south along the Monash. And of course, we own Westgate Tunnel Project, which hopefully is going to come online next year. So magic. So that's Transurban. So let's get into this. So I'm going to give a very quick, my agenda is I'm going to talk about this bridge, this famous bridge of mine that I love to death. Give you a quick breakdown of the bridge layout, some of the load tests that we did, and then the purpose of what we were doing on structural health monitoring is the performance assessment of this bridge. And then I'll just give some conclusions about what I learned. So very quickly, this is a 1960s precast segment post-tension concrete bridge. The short span is about 14 meters. It's continuous over the pier. The long span is 46 meters. We have a fixed end bearing at the southern end and an expansion bearing at the northern end. And our minimum clearance is 5.3 meters. So that's the bridge. So we did some strengthening on this bridge because it was of great concern to us and we needed to keep it open to traffic. We had a load limit on it while we were doing strengthening. So we did some load tests after we had done the strengthening, and what I did was I used T33s and T44s and T55s trucks, and that funny little blip underneath the bridge is my strain gauge. And I directed the truck to drive onto the bridge, stop with his front axle over the strain gauge. The process was then the second axle, stop over the strain gauge. Rockfield assisted us with this. They were sitting in Townsville and making sure that the data was flatlining before we moved on. So I moved on with this process until eventually the last axle was over the strain gauge and the truck exited the bridge. So this is what the data looks like. You can see at the start, the truck arrives on the bridge where you see the excitation. That's where he puts on brakes. Data flatlines, and we do the same process for second, third, fourth, fifth, sixth axle, and he disappears off. So we did this for northbound, inside and outside lane, southbound, inside and outside lane, 33, 44, 55, 2 times 44 is a whole lot of data. And then what I had to do was then realizing that the results I'm getting from the strain gauge, I can't directly relate that back to performance. So also understanding that I work for Transurban and we don't have any software, although we're still trying to get one particular software going, which is an IT issue. So I used a very, very simple, very basic structural assessment of saying, well, the bridge is essentially a propped cantilever. It's fixed over the pier, it's propped at the expansion bearing, and did massive amounts of calculations, spreadsheets saying, okay, for each position of the axle, I'm going to get a bending moment, and of course the position of the center of gravity of the truck relative to what my starting point was, which is the pier. So I had loads of these bending moment diagrams. And so having then done that, you can see I then plotted the bending moment diagram for the position of the center of gravity relative to the pier, which is the horizontal axis at the bottom, and the data that I got from the 2 strain gauges under each carriageway. From this, it was, I needed to understand what is the maximum value. So simple equation, second moment, take the derivative, get the maximum bending moment at what is its location, maximum strain gauge values of both strain gauges. Did that 100 times. Having then understood that, I was then looking at the strain gauge data that was coming in, and I had to understand the background data of the strain gauge. So what I've shown over here is a very simplistic representation of vertical axis is the background data and with time. So pre-strengthening, it had some value, call it 3,000. You can see there during the strengthening, we did see a change, and post-strengthening works, the background data had a lesser value. Pick a number, it's irrelevant. Pre-strengthening, we had, you get something comes over the bridge, and what the values that we see reported in the dashboard is what I've shown there as the microstrain. And same bridge goes over post-strengthening, and I get exactly the same value. Having then spoken to my general manager and director saying to me, Desiree, what's going on? Did the strengthening not work? And I was scratching my head a little bit here as well. So I went back to, so what's happening? If the strain gauge, what's the strain gauge actually doing? So I said, okay, there's time 0. We put the strain gauge on the bridge, and it's got a length L0. So that is the background value when there's no load on the bridge. So we get loads coming on the bridge, strain B, meaning before post-tensioning, doing all our work, we come along, we post-tension the bridge, strain gauge shortens, which was really great, which means it worked. And the strain gauge now has a new L0, so the length due to post-tensioning. And then after tensioning, we get strains going over, so loads after the strengthening. And it then struck me, having drawn this great little diagram, that what I'm actually looking for is the change from the original background value to the maximum that we are seeing each time a load goes over the bridge. I'm sure for just about everybody in the room, that's pretty obvious, but that took me a mighty long time to get to. So what we have now is that this is what we had pre-strengthening. You can see the change there, and post-strengthening, there's the delta strain that I'm looking for. That is what's going to tell me whether my bridge performed and whether the millions we spent on the strengthening was actually worth it. So that's a quick look at, oh, sorry, I didn't mean to yell. That's a quick look at the background data before tensioning, and after tensioning, I just didn't show the diminishing value while tensioning because it's not relevant. You can see there I've got the actual background values. From my experience with this project earlier in the year, I realized that I need to check and make sure there's no drift. So what I did then, I looked at all the background data, got the average values out, and I said, okay, what's the change from winter to summer? Which are those results that are presented over there? Then what's the change from summer to winter in background data? Which, whoops, are those values that I had there, which I've now lost. Then I said, okay, from winter to winter, which is my 365 days, which is those two values over there, gives me that change. And then indeed, there was a slight residual strain in my strain gauges over 365 days. Then I said, okay, what's the change from before tensioning to after tensioning? And those are those values down there. So then trying to understand, well, what is the strain due to post-tensioning, which are these values that I've put here at the bottom, which is simply those values from pre-tensioning to after tensioning, and adding on to that the residual value. So the strain due to post-tensioning is what I've written down there at the bottom. Having then worked all that out, because now that the directors are still asking me, have we wasted money, and is this bridge working, and can I actually open it to 68.5 tons? We had a 44-ton load limit on it. So what I drew there is I had, from the previous graph where you saw I had all the parallels, the bending moment diagram, strain gauge values, plotted that load versus bending moment diagram, and then microstrain versus bending moment. And then, okay, pre-strengthening, a truck comes over the bridge, that's the strain that I get due to the load, which means that essentially I could translate that as a load coming over the bridge, which is 68 tons. Having then worked out what was the strain due to post-tensioning, which is the 120 for the one particular strain gauge, which I showed earlier, that then means that my new strain versus bending moment diagram sits 120 microstrain lower than it did before. And then the same load coming over the bridge gives me a residual, gives me a strain under the bridge of minus 20, call it minus 25 microstrain. And that is the difference that I'm looking at. That is what's going to tell me whether my bridge performed or not, and what can I open the bridge to the traffic that we had before. So this is then what I reported to the directors and the GM, saying that what I'm looking at here is performance of the bridge, and we're not looking at the load traveling over the bridge, which was part of what they were hoping to get out of the strain gauges. So what are my conclusions in all of this? Yep, I understand this was a very simplistic bending moment analysis because I don't have strand 7, I don't have space gas, I can't do grid analysis. So I had to do just simple, really simple engineering 101 bending moment analysis. This method is not adequate for OSOM, oversize, overmass assessments. We get a lot of queries, can we send 300 tons down the road? Definitely not this bridge. but it is sufficient for 68.5 ton B double assessments. Naturally, of course, as you can see, there's no load factors applied in this, so this was a serviceability assessment. One of the big problems that we did during our load tests, I didn't have both carriageways closed. The two carriageways are connected by a link slab. When a track goes over one side of the bridge, that link slab transfers load through into the southern link slab, the southern carriageway. The transfer is about 10% of the load. That was monumentally unexpected. What I also learned over the year of monitoring this bridge is that the temperature of the temperature compensation on one of the strain gauges was not as efficient as it should have been, and there appeared to be drift, which then we could see from winter to winter, the drift was a whole lot less. The other thing, of course, from this exercise that I cannot make any comment on is during the post-tensioning, of course, the bridge has got a vertical curve as well as a vertical profile. So how did all that affect the values that I got in the strain gauge? And how do I take that out to say, yep, okay, this is the actual performance of the bridge? For the purposes of what the director asked me, I think that what I have done here is reasonable, and we have safely opened the bridge to traffic. So that's it. Thank you very much. Right. I think
thank you so much, Desiree. Very interesting case study. So I haven't introduced Desiree. She is also an advisory board member of ANSHM. So thank you so much for your support last year. And so because of time, we can have 2 questions from the floor. Yes.
Great idea. The question I have is, what kind of gauges were you using? Were they the vibrating wire kind or vibrating wire? Okay.
Yes. So when I listen to this, I also have the similar question. So what are the gauges? And also very interesting that, so for academic, because of that, we may try to install another gauge just next to it to see, maybe using other gauges to see, is it the drifting is due to the gauge itself or due to some other issues? That's very interesting in things that to explore. Another?
I have a quick question. Yes.
Yes. Yes,
it wasn't stated so, but why the strain gauges and not a thermal effect on the bridge? How did you subtract that, or is it on the baseline?
I think what you're asking me is how did I know that the drift in the strain gauge was not the bridge expanding, but the problem of the strain gauge? Because there are 2 strain gauges next to each other beneath the carriageway. And when I look at the difference, so when we started out, the difference between the 2, each time something went over was, pick a number, 10 microstrain. Then as summer came, that difference increased for the same load. So I went back and I looked at the background data and I looked through a whole lot of analyses and I looked at it this way and that way and chopped it and changed it. And I came to the conclusion that one particular strain gauge was starting to read higher and higher and higher compared to the other one. I had engine analysis helping me with this a whole lot because, yeah, Excel is not so great. And again, that is our go-to all for every problem we solve. So engine analysis helped us with that and came to the same conclusion. And by the time our contract was signed, it was already 3 months later and we were starting to enter winter. And then they confirmed that, yep, it is definitely, it is drifting due to temperature and then coming back in winter. Yeah, so thank you.
Okay, it's just the last question. Okay.
Hi, Desiree. Thanks for the talk. Arash spoke about the challenge of connecting industry to academia when it comes to structural health monitoring and the use of some of this instrumentation and technique and approach. for managing bridges. And you've mentioned you've had some discussions with GMs and directors internally at an organization that operates and owns assets. And I'm just curious to know what your observation has been about how the value has been perceived internally. And you had to go back to 101 first principles at this point in this project to get to where you needed to get to be confident to advise upwards. I'm just curious about what the perception's been internally about the value of structural health monitoring.
Aha. Two answers to that. Transurban has gone through a major restructure. So the people who valued it are no longer there. I mean, other than me. How has it been perceived at this stage? I don't actually know. The one director who was tapping me on the shoulder all the time, yeah, he does have an engineering background, and so he does appreciate what we do, but he's only one GM out of a whole lot, and he doesn't manage our stream of work. So for me going forward now, because we've just finished our organizational change, is to convince our new GM, who is, no offense to anybody in the room, ITS, and understands nothing about interesting engineering. So, so that's my challenge going forward. As you know, because you know our network, we have other issues where, yeah, we do need to have some real-time monitoring to see what's going on. So that's my next push. But yeah, good question. Thank you.
Yes, very good. So thanks, Desiree. I think in the panel discussion, we can discuss that further. So every year in that industrial forum, I think that the involvement of academia in industry or industry in academia is getting, and we need to getting closer and closer to explore questions deeply. I think we're in the right direction. And also I hope that research hub, when we establish, it will help. Okay.